Hello. In this short presentation, we want to show you the interface of our Hierarchic Language Abstraction Model processor, which allows you to take the plan generated by the PDDL in PDDL language and interpret it with our model and visualize it as in this web interface. So we've preloaded several different examples. So the first one is the example from the very well-known logistics scenario, which you can hear by clicking on the domain. You can visualize the domain of this problem. This is the definition of the problem. And this is one of the exemplary plans. So we have 3 different plans that we've preloaded for you. You can paste any of the plans in these domains as you would like. In the middle, we have the definition of our hierarchic language abstraction model, and on the right is the visualization of how this model was interpreted. So, for example, for the logistics, we have several different interpretations. So we have one from the point of view of a dispatcher, one from the truck driver perspective, and together we will do the airport traffic interpretation. So let's look at the dispatcher. So for the dispatcher, probably wants to know that the path of each of the packages. So going from package 1 is going from Parkville to airport, package 2 is from Flemington to airport Sydney, and the last one from Glenelg to airport Sydney. You can see how the hierarchy language abstraction creates a hierarchy of explanation. So we see that we start with package tracking of package 1, which is then hierarchically decomposed into a truck journey and then the plane journey. And here in the truck journey, we can see the whole path. So in Parkville, we load the package, we drive the truck, then we drive it again to pick up another package, and then we unload the truck at the airport. You can see that these 3 parts are in the natural language, while the last one is not. We just left it there as an example. So for example, we can change that. So here in the interpretation for the plan description, we can create an interpretation of also the unload truck. And if we do unload truck, we see unload. This is the first parameter of the unload truck, which we can see here in the domain, what the parameters are. So we have 3 different parameters: the package, the truck, and then the location. So we say we unload package from this truck. Yeah, so from truck B truck, and where, so in the location. Right? So you can see how any change in interpretation directly reflects to the change in the interface. So this is how you can see these bits, right? If we change the problem, we can see it generates different visualizations. So here we have 5 different packages, and we have the visual representation of the journey, which looks a little bit better and extracts all the information just from this plan using this specification here. As we've mentioned, we can also have different interpretation for different end users. So for example, we have an interpretation. This one is aimed at dispatchers. This one is aimed at truck drivers. So for truck drivers, all I want to know is what kind of deliveries is my truck doing. So for example, I want to know if it's I'm a truck driver B. So this is the whole report of what my truck is doing. All right. So this is a report for truck C. So you can see also the interpretation is much simpler, and also the plan description. Furthermore, our model also allows for automatic generation of filters. So for example, clicking on this button, it automatically detects the bound variables. So for example, I can visualize just, for example, tracking for package 2, or I can just set for all the packages going from Glenelg, and so on and so on, right? So similar to here, if I click on this, these are all the bound variables within this hierarchic abstraction, right? So I can furthermore filter by these values. All right, so let's try to create an interpretation together. So we can create interpretation both in JSON and YAML. So let's just switch to YAML for the sake of this example. So we're going to create a plan descriptions, and then we are going to also create our views, right? Here we have just some errors which we haven't worked with now. So first of all, we're going to create airport traffic model. So let's call this airports, and then we'll do a description, and we call them airports again. So it's nothing too fancy. And then we will specify my views. So basically, in the view, we have to specify which is the first line that we'll consider in this abstraction. So the start line for this view would be either, so it's an array, so would be a fly airplane. And the parameters we can see here are in the fly airplane, we have the airplane and then from and to. So we don't care about which airplane it is, but we will consider our airport. So we'll bind this variable airport and then with unbound variable to. And we also consider, so this is coming to, so this is arrival. And then we also take all the departures. Fly airplane, then plane, and then from, and then to my airport. Port, right? So I have all the traffic where coming from our airport to some destination. So this is departure and then the arrival. And so coming from any airport to my airport. So if we expand this, we currently have no matching lines. So what we have to do is to create a view which will extract the lines from the plan and create the airport traffic abstraction. So what I'll do is I will use for all the extracted lines, I will define a new view and I will call it airport traffic. And I will use this newly bound variable airport for this given airport, right? So I will put exclamation mark and then do the airport. So here I bind the value of the airport and here I use the bound variable of the airport. And it's telling me that the view does not exist, right? So I don't have that view. So this will be a top level view. So that's not a sub view of this view. So let's create a new one. So let's call this the same way as here, airport traffic. And then we will use this bound variable here, airport. And if we unzip this, we have 3 different airports, which is good. And now I can do the description here. And I will say traffic in airport. And then I'll use the value of my bound variable. Traffic in airport. Adelaide. Oh, it's airport there, so let's just do this. Traffic in airport Adelaide, airport Melbourne, and Perth. Right? So you can see how automatically this is being generated. And now the last bit is I want the traffic lines. So what I'll do here, I will say that which plan lines I want to consider. So in this case, I want to use plan lines in a sequence. And in this case, the sequence is quite simple. All I'll do is I'll use a fly airplane. And then the fly airplane has a parameter of a plane and then from and to, right? So I use any, I don't use any bind variables. I just extract any fly airplane from what I've already extracted. If I do this, I can see here the different traffic, right? So I have my fly airplane actions, and I can use again my plan descriptions for fly airplane similar to previously to make this look a bit nicer. And I can continue decomposing this into more complex hierarchic abstraction to get to the level of the detail that I require. Thank you very much for listening. I hope you like this.